Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the concept of the multiplexer and the demultiplexer. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the concept of the encoders. Now, let's see the basic introduction about the encoders. Encoders are the combinatorial circuits which is designed to perform the inverse operation of the decoder. Generally, we can say that encoders and decoders are the code converters, where the encoders converts the human language codes into the machine language codes and decoder converts the machine language codes into the human language codes. An encoder has the 2 raised to n number of input lines and n number of output lines. That means the encoder has the 2 raised to n input and n output lines. For example, we can say that if the encoder has the 2 raised to 2, that means 4 input lines, then it has the 2 output lines. If the encoder has 2 raised to 3, that means 8 input lines, then it has the 3 output lines. I hope you all understand the basic idea about the encoders. Now, let's see the types of the encoders. Generally, in this video, we are going to see the 3 types of the encoders: decimal to BCD encoder, priority encoder, and 3 by 4 matrix keyboard encoder. Let's see details about each type one by one. The first one is the decimal to BCD encoder. We know that the BCD stands for binary coded decimal number, and which is a decimal number represented by 4-bit binary number. We already learned about the BCD code. Now let's see a short look on the BCD and the decimal number system. Let's see, a decimal to BCD encoder is also known as 10 line to 4 line decoder. Why this is called as 10 line to 4 line decoder? Because we know that there are total 10 decimal symbols starting from 0 to 9, and each of the symbol can be represented with the 4-bit binary number 0000 to 1001. Okay, that means from 0 to 9. Hence it has 10 input lines and 4 output lines. Okay, I hope you all understand the basic idea about the decimal to BCD encoder. It accepts 10 inputs and produces 4-bit binary output corresponding to the activated decimal input. This is the block diagram of decimal to BCD encoder, in which we can see that there are total 10 inputs from Y0 to Y9 and 4 outputs from A0 to A3. Okay. Now let's see the truth table for the decimal to BCD encoder. Here we know that the truth table is the graphical representation of the inputs and the outputs in a single table. Okay, here we can see that there are total 10 inputs ranging from Y0 to Y9 and 4 outputs ranging from A0 to A3. Now let's see the details about this truth table. Okay, consider the first input Y0 is 1, that means we press the 0 number decimal input, then we get the output as 0000. If the Y1 is pressed, that means if we press the decimal input 1, then we get the BCD code 0001. Similarly, if we press the 9th number pin, that means Y9, or if we press the decimal number 9, then we get the binary or the decimal code 1001. By this way, we can draw the truth table for the decimal to BCD encoder. Okay, I hope you all understand this truth table. Let's see once again. If the 0 number is pressed, or if y0 is 1, then we get the code 0000, that means decimal 0. If y1 is 1, then we get 0001, that means the decimal 1. If y2 is 1, then we get the code or the BCD number 0010, that means decimal 2. If y3 is 1, then we get 0011, that means decimal 3. Similarly, each input is 1 at a time and we get its respective BCD code. Okay, now let's see the Boolean equations regarding to the outputs. Let's see the Boolean equation for A0. Okay, here see here the A0 is 1 for how many times? 1, 2, 3, 4, 5. That means we get the addition of the 5 terms, such as here A0 is 1 for y1, then y3, then y5, then y7 and y9. That means we get the equation of A0 as y9 plus y7 plus y5 plus y3 plus y1. I hope you all understand how to find the logic equation for A0. Now try to find the logic equation for A1. Here let's see the A1. Here A1 is 1 for 4 times. Okay. Now try to find here A1 is 1 for y2, then 1 for y3, then for y6, and then for the y7. That means we get the logic equation for A1 as y7 plus y6 plus y3 plus y2. Okay. Similarly, we can find the logic equation for A2. Here A2 also high for 4 times, like this. Okay, that means here we get this one, this one, this one and this one. That means we get the equation y7 plus y6 plus y5 plus y4, y7 y6 y5 plus y4. Similarly, we can find the equation for A3. Here A3 is 1 for only 2 times. That means here we get the 1 here, and in this row we get the 1 here. That means we get the addition of only 2 numbers, y9 and y8. Okay, I hope you all understand how to find the logic equation for A0, A1, A2 and A3. Now let's draw the logic diagram for this equation. The logic diagram is very simple. First draw all the lines like y0, y1, y2, y3, y4, y5, y6, y7, y8, y9. Then first find A3. A3 is y8 plus y9. That means y8 plus y9. Here we have to put OR gate for the addition. Here we get A3. Okay. Similarly, we can find A2. A2 is Y7. That means Y7 plus Y6 plus Y5 plus Y4. Here we get A2. Similarly, we can draw the logic diagram for A1 and A0. I hope you all understand this diagram. Here in this diagram we can see here that A3 is the ORing of Y8 and Y9. Okay. Similarly, A2, A1 and A0 is represented by the OR gate. I hope you all understand the decimal to BCD encoder. Now, let's see the next type of encoder, priority encoder. In priority encoder, there are total 4 inputs, that is D0, D1, D2 and D3. D0, D1, D2 and D3, and 2 outputs, that is Q0 and Q1. The D3 has the high and D0 has the low priority inputs. This is the very important statement here, that the D3 has the highest priority while D0 has the lowest priority. When more than one input is 1 at the same time, the output will be the binary code corresponding to the higher priority input. That means, consider here that if D0 has the value 1, D1 has the value 1, D2 has the value 0 and D3 has the value 1, then what is the output of this encoder? Here we are seeing the priority encoder, and we know that the D3 has the highest priority and D0 has the lowest priority. That means the priority decreases from D3 to D0. If D3 is 1, then there is no value of D0 and D1. That means the output is corresponding with D3 only. Okay, I hope you all understand here. Now let's consider again the situation here. D0 is 0, D1 is 1, D2 is 1 and D3 is 0. Here now the output is corresponding with the D2 only, because after D3, D2 has the highest priority and D1 has the lowest priority, and the output will always in corresponding with the highest priority, which has the D2 input. I hope you all understand the priority of the encoder. Okay, now let's see the truth table regarding to the priority encoder. The inputs are D0, D1, D2, D3, out of which D3 has the highest priority, D0 has the lowest priority, and the outputs are Q1, Q0. Okay, now if D0 is 1, if D0 is 1, that means the input of lowest priority is 1 and other inputs are 0, then we get the output 0 0. Okay, this is the very simple condition. Now consider D1 is 1, that means D1 is 1, then and D3, D2 is 0, then there is no value of D0 whether it 0 or 1. Here x represents the don't care condition, that means x may have the value 0 or x may have the value 1. There is no value of D0 when D1 is 1. In this case we get the output as 0 1. Similarly, in next condition, if D2 is 1 and D3 is 0, in this case the D1 and 0 has no value, because they represent the don't care condition whether they have the value 0 or value 1. Then it the output is only the D2 because D2 has the highest priority with respect to D1 and D0. The output in this case is 1 0. Similarly, if D3 has the value 1, then there is no matter that the D0, D1, D2 has any value 0 or 1. Okay, because D3 has the highest priority, and in this case the output is 1 1. I hope you all understand this truth table. Now let's see the KMap for Q1 and Q0. Here, understand here that the inputs are of 4 bits. That means there are total 16 states. That means 16 boxes. Hence, we use the KMap for the 4 variable. Okay. Then for this Q1, we get the 1 1 here. Okay. The 1 1 for this condition, and according to this truth table we get this KMap. In this KMap we get the two octets, and the equation of the two octets are D3 plus D2. Okay, D3 plus D2. Similarly, we can find the KMap for Q0, and in this KMap we get one octet and one quad. We get the equation Q0 equal to D3 plus D2 bar into D1. Okay. Now we can draw the logic diagram for Q1 and Q0 like this. Here we can see here that Q1 is D3 plus D2, that means D3 plus D2 plus means we put here the OR gate, hence we get Q1. Q0 is D3, that means here D3 plus D2 bar, that means D2 bar, here the not get connected, hence we get here D2 bar into D1 into, for that purpose we place here AND gate, and we get here Q0. I hope you all understand how to draw the logic diagram for the priority encoder. Now let's see the last type of encoder, 3 by 4 matrix keyboard encoder. A keypad or keyboard encoder is most widely used as an input device. Generally, it is used with microcontroller or microprocessor based device. Matrix keyboards are arranged such that keys are in matrix of the rows and columns. Here we can see that there is 4 rows and 3 columns, hence we called it as 3 by 4 or 4 by 3 keypad or keyboard encoder. In this we can see here that each row and each column, at their join we place a key. Okay, like this. Hence, it forms a matrix-like structure, hence named as the matrix keyboard. In actual image, the 3 by 4 or 4 by 3 matrix keyboard is like this. Okay. Now, let's see working of this keyboard. When a digit key is pressed, the internal circuit understand which key is pressed, and keyboard encoder will give a code corresponding to key pressed. Here the key is pressed in between each row and each column. Okay. The pull-up resistor make the input line high when the switch is not closed. Here these resistors are called as the pull-up resistors. That means they work as when the key is not pressed, then it holds the value high. That means it holds the value plus 5 volt. In digital logic we can say that by using the pull-up resistor we can continuously make a line to one state. Okay. When a switch is closed, the corresponding line will be connected to ground. This provides low level to the corresponding input to the encoder. That means when this switch is pressed, consider S1 is pressed, then this line, that means this row, is connected with the ground. That means it is now becomes 0. I hope you all understand here. For example, when key 4 is pressed, that means this key is pressed, then the column 1, that means this column 1, and row second, this row second are shorted. Okay, that means there is a connection like this. I hope you all understand the concept here. Here in this animation we can see here that if any key is pressed, for example, if ninth key is pressed, sorry, if the sixth key is pressed, then the column third and row second is short. I hope you all understand this concept here. Okay. Now let's see the applications of the encoder. The encoders are normally preferred where there is a need to convert information of code from one format to the another format. In addition to the linear and priority encoders, encoders have many applications as listed below. Keyboard encoder for computers, optical encoders, that means they are further divided into two types: linear or rotary encoder, interfacing peripherals to microprocessor, and audio video coding and transmission. I hope you all understand the basic idea of encoder and the working of its types. Thank you.